All right, our next little looping exercise is going to be done kind of similar to the one that we did in the previous lesson. I'll lead you through in this video. Whenever you need to pause the video, you can pause it and go do part of the program and then come back to whenever you need to. Play more video, go do more program, play more video, do more program, just like the previous. Here's the problem we're going to work on today. It's another one of those, this probably has a ridiculous answer problems. Here it comes. 32 people are making a stack of paper. Think of a line of 32 people all lined up. They all have some paper. Why would they do this? I have no idea. But just go with it, right? The first person is going to put down 2 sheets of paper. They're going to walk up and lay down 2 sheets of paper. The second person is going to put down twice as much of that as that, so that would be 4 sheets. You're going to lay down 4 sheets of paper. The third person is going to come along and put down 8 sheets of paper, so it doubles every time. So the next person always puts down twice the number of sheets of paper as the previous person. All right. So each sheet of paper we're going to say is 0.076 millimeters thick. I don't know how accurate that is, but we're going to go with it, right? How high will the stack be when the last person has laid down their paper? Picture it now. Everybody's going to walk up and lay down some paper, and the stack's going to get higher and higher. So how high is it going to be when all the paper has been laid down? And again, before we get into this and before we see a right answer, at least in your brain, it doesn't have to be any big deal, but at least think, is it going to be as high as the ceiling? Would it be as high as the building, or as high as your house, or what kind of thing are we talking about here? How high will the stack be when the last person's gone through? It's 32 people, and the number of sheets doubles every time. So, same deal as yesterday. I would watch some video and pause it when you need to, and then add, go do part of the program, and then come back to the video and go back to the program and back to the video and back to the program, and just do that as much as you need to get through. I'm going to show you the right answer by the time we're all done with this. I've got some description of how to do this, but really the thing that's going to be more helpful is just watching. So now let's visualize this just real quickly here. So again, here's the deal. The first person is going to, this is terrible drawing, but the first person is going to come along and lay down 2 sheets of paper. Then the next person is going to come along and lay down 4 more that are going to be on top of that. So we had 2 here and we had 4 here. So now when those all get put down together, you've got 6. And then the next person is going to come along and lay down 8. They're going to lay down 8. And so you've got 8 and 6, and so that's going to be a total of 14. And so the paper is just going to get higher and higher and higher and higher, and there are 32 people. Okay. Well, so rather than try and sit down and figure it out, let's write a computer program that will figure it out. So I'm over here on the Game Lab now, and I've already started a new Game Lab project. We're not really going to shoot the output out to the game screen over here. We're going to shoot it out to this Debug Console down at the bottom once again, like we did yesterday. All right, so it all starts like this. We're going to have some variables. We're going to be counting some things. So I'm going to go to the variable drawer. I'm going to use the first one here. This is where we need the var part of it. So I'm going to bring over 1, 2, 3 of those. What are we going to be counting? Well, we're going to be counting, now I'm going to say person, but we're counting people. And we're going to start that off at 1, because the first person in line is person what? Person number 1. So we're going to start it that way. All right, now let's think about sheets of paper. How many sheets of paper does the first person have? 2. That's just part of the problem. That's a given. That's what they call a given in a problem, right? Some of the information that is given to you as we solve the problem. Now, the other thing we're going to have to kind of keep track of is, okay, how many sheets are in that stack? As the stack piles up, how many sheets are in the stack? And that's going to start at 0, right? It's going to be that to begin with, nobody has laid down any paper, so the stack begins at 0. So this would be a place. This would be a place where you could pause the video and go do that much, right? It's just 3 variables. So if you need to pause, go do it. And 3, 2, 1. Okay, you're back. All right, so now let's start with all of the, we've got some calculations. We're going to spit out some data. So let's get going on that. All right, first thing, and this is going to be the third variable block down here, not the var. Don't use the var. It's just the one that says x equals. So I'm going to bring it over. And the first thing we're going to do is we're going to grow the stack. All right, the stack has to get bigger. So I'm going to say stack equals stack plus. Remember, that's kind of how you always do, like if you want to increase the value of something, the number of sheets on the stack has to get bigger and bigger. All right, so plus what? Well, it's going to be plus the number of sheets of paper. Like, just think about person 1 right now. Person 1 walks up, lays down 2 sheets. Well, okay, so that 2 is stored in the variable sheets, and so it's going to look like that. Okay, so that's not much, but you could pause the video and go do that. 3, 2, 1, you're back. Okay, now here comes, again, another one, kind of a long series of these console.log messages. All right, because again, we're not going to spit the data out over here on the game screen. We're going to spit it out on the debug console here. It's just text that we're spitting out. All right, so the first one here is, and I'm going to go do that whole thing where I go to the math drawer and I'm going to bring over a plus block because I'm concatenating. I'm putting some things together here. So we're going to kind of fix up a little report. This is going to say person space quote, and then over here I'm going to put the variable person. Now notice again, like we've done before, the first one has quotes, the second one does not. It's because the second one is representing this variable right up here. This one, I just want that actual text, so it's going to say person 1. All right. Now as we go along here, we'll go back and get another. Oh well, pause the video and go do that if you want to. And you're back. Console.log, and this one, once again, going to go get a math block here. Boom. And this one is going to say, the way I'm going to say it, sheets in the stack. We're going to keep a running total of that. Space quote, right? Could put, you know, I could put a colon in there. That might look kind of good. All right, and then this is going to be stack. Okay, and this is, again, we're just kind of a little report. How many sheets are in the stack now? Somebody's walked by and laid down some paper. How many sheets are in the stack? So it's sheets in the stack, and that's in quotes, and then the variable stack matching up with that right there. That's not in quotes. All right, so I'm going to do that. If you need to pause the video and come back for the next part. And you're back. All right, so console.log once again. Okay, again, going to use a couple of kind of a math block here. All right, cool. And this is going to say, now we get into how high is the stack. So what I'm going to put here is height, stack in millimeters, mm for millimeters. So that's going to be the first part here, right? Remember, because what I've reported so far is just the number of sheets of paper in the stack. That didn't tell me really how tall it is. It tells me how many sheets of paper are there, but not how tall it is. So this is going to be, how high is the stack in millimeters? Okay, well, so that's going to involve a little math here. We're going to have the number of sheets in the stack multiplied by, that's Shift 8 on your keyboard, or it's a star key, and it's 0.076. We said that's what we're going to use as the thickness of a sheet of paper, 0.76 millimeters. All right, so that should give us the, how high is it in millimeters? So if you need to pause the video and go do that part, go ahead. And you're back. All right, on we go with our console.logs. All right, so the next one, once again, I'm going to keep doing this whole boom, boom, bringing down the plus block here. This one, we're going to do some conversions here. Do we want to cap? Nah, that's all right. I'm going to do stack in meters. Oops, I didn't put a quote at the start of that, so that is going to have a quote at the beginning. Okay, there we go. Stack in meters. Okay, this is in millimeters, and I want to change it to, okay, how many meters would that be? All right, so that's going to be, and I'm just going to do kind of a long math thing here. So that's going to be stack. It's going to be the same thing we had before. Stack times 0.076. How do you change millimeters into meters? Divide by 1,000. Not 100, 1,000. All right, so again, take a look. And when you click off of it, it's going to kind of break those out into some separate holes, but that's okay. That's all fine. So again, take a look at that. Stack in meters. That's in quotes. Stack times 0.076 divided by 1,000. That's what we're doing. We're converting millimeters to meters. So it looks like that. Take a good look. If you need to pause the video and go do that part, go ahead. And you're back. All right. Still, we still have a couple of console.logs to throw in here. This one gets even crazier. Now, we're going to do stack in miles. All right, so that part, oh, you know what? Sorry. I forgot to put my plus block in there. My bad. All right, so the first part should be, quote, stack in miles, colon, space, quote. Okay, better. Stack in miles. Because we're not that, I mean, well, maybe you are. How familiar are you with meters, right? Are you real comfortable with the metric system? But how tall would this be in miles? And now you start to get a little clue. Oh, wait a minute. Do we even have to measure this in miles? Spoiler alert, yes. It's measurable in miles. Sorry, I can't talk. All right, so it's going to be kind of a long equation here, but watch. It's going to be stack. It's all the same things we did before. Stack times 0.076 divided by 1,000. Because this is all multiplication and division, the whole order of operations thing works here. Divided by, here it comes, 1609. You know why they call the 1,000 meters in track and field is kind of like the mile? Or the 1,600, I'm sorry, the 1,600 meters is kind of like a mile? Because that's how many meters are in a mile right there, 1,609. All right, so that's again long, weird-looking thing. Stack times 0.076 divided by 1,000 divided by 1,609. And when I click off of it, it's going to break those out into like separate holes, but that is okay. All right, if you need to pause the video and go do that part of it, take a good look at it. But that's how it's done right there. Pause the video if you need to. Go do it. And you're back. All right. Now we're almost done. You're almost done. This one is just going to be, and I did this in the previous video when we did the allowance problem. I'm just going to make a console.log that has quotation marks and just has a bunch of dashed lines. You could use some other character if you wanted to. All that does is just kind of make it's going to be like running a report of all these, okay, person 1, person 2, person 3, person 4, person 5. And this separates each person. It makes it a little bit easier to read. It looks a little bit better. All right, so that's not, I mean, if you want to pause the video to go do that, go ahead. That's not a hard one. Quote, whole bunch of something, and then quote. All right. Tick tock, tick tock. You're back. All right. Now, just a couple of calculations. This is very nearly over. Now we're going to use the x equals block here, and we've got to do a couple of things. What happens to the number of sheets of paper as each person walks up? All right. So we got to think about that. It's sheets. The new number of sheets for the next person equals the old number of sheets. What happens? It's times 2. It doubles. All right. Sheets equal sheets times 2. So we got to plug that in there. And why don't you could pause and go do that, but there's another one coming here that's real easy as well. I'm going to bring over another x equals. And this is where and I forgot something very important here. But we'll fix it here. I forgot like the most important thing of the whole shebang. But I'm not going to go back and do the video over it. We can fix it. Person equals person plus 1. We're counting people, right? Now I should say, pop quiz, what I forget. I just got carried away and I went straight into doing all this stuff and I forgot, like, yeah, just only the most important thing of the whole deal. Does anybody know? Anybody know? You probably do. I forgot to put in the while loop, but we can fix this. Watch, I'll show you. I'm just going to go to Control. I'm going to get the while loop, and I'm just going to pop it right there. Okay, look. And maybe you didn't forget. You might be smarter than me, and maybe you didn't forget. So I'm going to put the while loop right there. And what is it let's think about what it is we are. What are we doing here? While how do we know when this whole thing is over? It's people, isn't it? When the 32nd person has walked by, this is done. This is over. So I'm going to say, as long as, that's another good way to say while. As long as person is less than, what's the last one? 32. So I'm going to say is less than 33. All right, so as long as person is less than 33, or as long as, while. Okay, now we've got to move all of this stuff inside that loop. So I got it all like lassoed there, all selected, and I'll move it inside the loop. Can't believe I forgot to do that, but at least I caught it, right? At least I caught it. Okay, mistakes happen. All right, so now I believe we have this thing looking the way it should look. Cool. And really, to tell you the truth, I don't know that we really need a draw loop, but I don't think it's going to hurt anything. Okay. Well, moment of truth. We ready to run this puppy? Let's try it. Let's hit run. Sometimes it takes a little time for it to do the calculation, and sometimes, and because of all the changes I made, I may have to come up here and just refresh the entire page once. That happens sometimes as well. You just have to refresh the whole page, and then you go run it. All right, I've got some results down here. I'm going to pull up the Debug Console. There's 3 dots on the top of the Debug Console allow you to pull it up. And I'm looking at my report. I'm scrolling up and down my report here. Person 1, sheets in stack 2, stack in millimeters, stack in meters, stack in miles. If you're looking stack in miles, it says 9.4. You're thinking, how can 2 sheets of paper be 9.4 miles? It's not. Look at the E minus 8 at the end of that, and that means you would have to take that decimal point 8 places to the left to make that's exponential. So you'd have to take that decimal point 8 places to the left to actually see the number and add all those zeros in there. So don't let that fool you. It's doing scientific notation is what it's doing there. All right, so I scroll. Let's cut to the chase here. Look at that. That's in miles, people. That's in miles. This stack of paper, if we really did it, which we can't, it's impossible, is 405 miles high. Yikes! That's another one of those problems that you don't think it's going to be that big, and it turns out to be ridiculous. Absolutely ridiculous. So here's the thing that is kind of important for you. If you didn't get 405.739, etc., something's wrong. And you would have to get back up here and look at your program. Look for something you might have done wrong, work on fixing it, email me if you're at home and I can't figure it out, and you're at home, you can email me. Obviously, if you're in class, you can just ask me. But that's what we're shooting for right there. There's your output, and 405.739 with more numbers. That is your answer. That's your right answer. Okay, let's give it a shot.